Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting two electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the two bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson Behaviour of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge, in this case, electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. There is more detail about this process in our lesson Interpreting Electrode Equations. There are special names for the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called the anode, it attracts anions, and the negative electrode is called the cathode, it attracts cations. The liquid is effectively conducting electrical current. The only difference is that the charge carriers in the liquid, in other words the charged particles that are moving, are ions. If a liquid has free moving ions and can conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in ionic solutions as well as molten compounds. The more concentrated that solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. We'll be studying several examples of electrolysis in more detail in other lessons. For the time being though, here is a summary of the key ideas about electrolysis. Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move and carry the electrical charge.